Hi, I'm Daniel White.
Yeah, and David Garcia with WCS Engineering.
Yeah, this cartoon was published several years ago in Jefferson County following a large spill. Now, that spill has since been corrected, but Jefferson County still has SSOs. They still persist. In fact, whether SSOs are number one driver in our capital improvement program. As water professionals, we all know that the public really deserves more than excuses, and it's our duty to provide the best, most effective solutions that are the least burdensome. And we believe what we're presenting today is an approach for that. So the county has a 25-year history with capacity improvement strategies for peak flows. Right, those former plans, they really focused on larger treatment plants with on-site storage at the plant, larger pipes, and maybe we achieved as much as 20% I&I removal through CIPP. Following 2008, financial constraints the county was in really forced us to adopt best management practices in terms of asset management, but also looking at better engineering solutions for our problems. We were looking for the biggest bang for the buck. We needed the best return on investment. We had tried many times, but we were really never effective at being able to forego capacity improvement projects with rehab only and I&I reduction through rehab, focusing on the main line and only on the lateral connection. But then we tried some different approaches, right? And I think we came up with a solution that's repeatable and effective for significant I&I removal through full comprehensive rehab. So with this change, right, being able to consider as much as 50 or 60% I&I removal for capacity reductions, Hazen and Sawyer, who we worked with on our model development and also on our initial remedial measures planning, brought to us WCS and their capabilities for optimized planning. So there was a concept of being able to take a well-developed hydraulic model, right, good engineering assumptions, well-established cost data, and then being able to evaluate just countless what-if scenarios of trying to come up with the right mix and also the right order, right, of I&I reduction, capital improvements, interbasin transfers, pump station improvements, just you name it. If you could consider it, if it was a possibility within our system, it could be considered through these iterative solutions. David is going to take over and explain this process.
All right, thanks. Yeah, so one of the key parts of this program, and before we even start the optimization, is that we need a well-calibrated hydraulic model that was used as the whole basis for this analysis. The model for this particular project was provided by our partners at Hazen and Sawyer, and we then took that into the optimization process. So kind of the key takeaways that I want to have everyone look at today and think about is, number one, how the cost savings of this approach, how much it reduces the total project cost over traditional trial and error modeling. The second one is how we looked at I&I reduction and were able to select and optimize and over 200 flow meter catchments and pick the right investment that balances I&I reduction, conveyance improvements, and storage and treatment at the plant. The third one is the approach that we took to do the sensitivity of that I&I reduction. Given the high numbers that the county was seeing in their I&I reduction plan, we wanted to see if they didn't continue to achieve those same results, how would that affect the strategy of the master plan? And lastly, about how we prioritize and pick projects to determine the best return on investment and which projects to construct first over the course of the implementation plan. So this first map here shows the reported SSOs throughout the collection system. This is 10 years of SSO history. And as well as referring to earlier when we said we had a well-calibrated hydraulic model, as we look over into the model system performance, then you can see how those SSOs correlate very well with the model predicted SSO locations and in the hydraulic model. So this next map here shows the complete range of improvement alternatives that we're considering as a part of these as part of this project. This isn't everything that's going to be built. This is everything that we have determined that could help solve the problem and is giving optimizer choices on what to select in order to eliminate the SSOs and achieve compliance with the design criteria. So the question is with all these alternatives, including I&I reduction, like I said, in over 200 catchments, how do you effectively analyze and compare and contrast these with each other and come up with the right balance of costs? So this is where we bring in the optimization platform. So we're called, at the heart of this is Optimizer from Optimatics. So it incorporates the hydraulic model, the improvement alternatives that we just looked at, a strong cost model, and the design criteria that we're trying to achieve. So all this comes into Optimizer, and we use the power of the cloud to run over 100,000 evaluations in combinations of all those alternatives in order to come up with a least cost solution. From that point, we then have the ability with this tool to quickly test and analyze the sensitivities and of the project. So in this case, the primary question is, what if I&I reduction is less effective? How is that going to change the strategy, and how important is that to selecting and designing the improvements? So this is a list here of the design criteria and the assumptions that were used for the project. The two most important ones that I want to point out is we're looking at 2 design storms in one optimization run. So we are looking at the 6-hour event to size that's using to size the conveyance improvements, and then the 24-hour event, which is controlling the sizing of the storage options in the system. And also, we want new sewers to be designed well so that they don't have any surcharge in them. And also, so we're not building big pipes into little pipes and back into big pipes. We want solid continuity to take forward into design. This is an example of here showing the cost model used for the analysis. The analysis takes into account total life cycle cost. So all the alternatives are being evaluated over their entire lifespan of the project, and everything will be compared on this at the end on this the total life cycle cost of the solution.
I just want to add that asset life is a really important factor for us as the owner of the asset, because it brings out not just SSO reduction, but our total investment into the system over a much longer window of time frame. It's a different perspective on solving this problem, not just the immediate SSO reduction, but what are my investments into the system over the life of the assets.
Thanks. Yeah, and here's another table that just shows even more the parameters that we took into account when developing the cost for each type of improvement. All these costs were generated by the county and our partners at Hazen. Okay, so let's start getting into some other results here. So we start with a bookend solution. So this is conveyance only. We don't want to overwhelm the optimizer with too many options at first. We want to see what is the most extreme cost solution here. So we only allow it to pick the conveyance only improvements, and we're just taking everything down to the plant. In this case, we're looking at real high cost of $1.2 billion capital and almost $1.4 billion in total life cycle. So the next step is then we start layering in different types of improvements. That way we can specifically see what is the cost savings that is related to introducing that type of improvement. So then we introduce storage to the optimization, and we rerun it and see what the least cost solution is with storage included. And you can see that the costs have reduced dramatically. But what's also handy is as we kind of flick back and forth here, you can see very clearly where those storages are contributing to removing required gravity sewer improvements. You can also see the size of those storages as is being designed and selected in the software. The next step here was then to introduce I&I reduction into the equation and see how does that affect everything. And so with this first solution, we start off with the conservative I&I reduction solution. So this is what if we spent the cost associated to eliminate, let's say, 20% I&I in a particular catchment, but in post-rehab monitoring, we see that we only got 10%. So we're still spending the full budget, but we're only seeing half effectiveness. And what does the strategy look like? And again, we can kind of go back and forth and see which catchments are being selected for I&I reduction, which I&I reduction levels is being selected as targets for each particular catchment, and where those are offsetting conveyance and reductions in storage volumes. So the next step here was then to introduce what we call the aggressive I&I solution. And so this is if the county were to spend all the money and got full effectiveness out of the program. And you can see here what's most interesting is that most of the catchments are the exact same locations as the conservative. So this gives the county a real strong platform and basis for chasing down I&I in those catchments, because it shows that no matter what the effectiveness is of the programs, they're still being cost effective in those locations and are contributing directly to SSO reduction and eliminating other alternatives, including conveyance and storage. There's a summary slide here showing all the solutions. So you see where we started off at the extreme $1.4 billion bookend. And as we introduced different types of alternatives, how we ended up down with the right two solutions, where we see the cost of the program could be anywhere from $617 million to $538 million, depending on the outcome of the I&I reduction. So the next step here was to prioritize the improvements and come up with a strategy for implementing these projects. So we set up the optimization, again, using Optimizer to select projects from the selected solution, and to develop that schedule of implementation that's going to maximize the return on investment. And so in this case, we want to reduce volume of SSO, and we want to reduce the count of SSOs. So this is the results of this analysis. And there's a lot going on here, but what's most important is looking at that black line right in the middle. So that's showing the reduction in SSO volume and count, and the total expenditure at each of these priority tiers as projects are implemented. The data in the background shows SSO volume and count being reduced as different projects are implemented. So we're going to kind of step through these one at a time so you can see how the program is being built up. So this is a map of, again, showing the existing system. This time we're showing the SSOs in black and yellow dots. And as we look in the graph in the lower right corner, you see that we've invested no money at this point, and this is full. We have all the SSOs being activated. So as we look at the priority 1 projects that are selected, we can toggle back and forth, and we can see where those initial projects are contributing directly to elimination of SSOs. So the priority 1 projects here are a few catchments of I&I reduction, and then a couple of small conveyance improvements to relieve some serious system bottlenecks. And what's interesting with this first pass of priority 1 improvements, you can see in the upper right corner, so we've already reduced our total volume by almost 20% by only spending 3% of the budget. So then we look at the next year, and we start introducing new projects. Again, all these projects have a similar return on investment and contribute directly to that volume reduction. So we step to priority 2. You see the volume being reduced and expenditures going up. Same thing with priority 3 projects. Again, SSOs are disappearing from the map, and volumes are being reduced. I want to pause here on priority 4. This is an interesting slide because now our first storage has been selected right in the middle of the map at Princeton Avenue, and then again in the lower left or right corner at Forest Glen. So these being priority 4 projects, these projects are so far out in the future that the county, they know that they need to start planning for these storages to be built eventually. But as we get through the I&I program and seeing the effectiveness, we can adjust the sizing of those systems as we get through the I&I rehab.
Right. We can measure, quantify, and then design for those actual conditions.
Right. And the locations are shown to be effective. So we know that we need to start land procurement and preliminary design in those areas early, since we know they have to be built eventually. We keep on going through priority 5, and now the numbers start to get more interesting as we get through the later priority levels. So now we've achieved 93% SSO reduction, and we've still only spent half of the budget. Now looking here at priority 6. So again, 99% reduction in volume, but we've only spent 3/4 of the budget, which means that last 1% is very, very expensive to be able to chase down and eliminate. And I think by having this strategy of continuously updating the model and seeing how the rehab actually comes out, then we can see if that last 1% is still going to be out there, or if we're expecting more, or if it's even worth to try to chase down in some cases. And then lastly, the last projects. So we show full implementation of the program. So again, here's that full return on investment curve, again showing all the projects being implemented and their impact on the total volume reduction. So yeah, I want to revisit those key takeaways that we talked about earlier. So we saw on this particular project about 20 or 30% reduction in total cost savings over the traditional trial and error solution that was previously generated for this program. We also were able to establish a maximum amount of money that should be spent in each flow monitoring catchment. That way to avoid that diminishing return on cost effectiveness. The conveyance improvements were sized conservatively based on that I&I reduction sensitivity, and that's going to allow flexibility as if the I&I program isn't as effective. We've got that conservative sizing, so the improvements can be built that way to expect the higher flows if we don't get full the full effectiveness of the I&I program. Lastly, we showed that the prioritization investment schedule, we were able to achieve approximately 80% reduction in SSO volume and counts, but with only 40% of the total capital expenditure. I'll let Daniel wrap up about how they're using these results in their program now.
Right. So, I mean, being able to go through and have this phased approach allows us to really hit on SSO volume reduction first. Taking that, bringing that into financial models as well, and looking at affordability issues, and just having a very iterative process of looking at our schedule, our funding, our finances, and bringing that all together so we can achieve these results that we're looking for. In conclusion, really to say that I've been very pleased with the process. The effort resulted in a phased capital improvement program, right? Prioritizes spill volume reduction. It supports asset renewal, and it allows this ability to measure, right, and then adapt, right? Time to measure and adapt and adjust to what those changing conditions are. A lot of assumptions goes into this on cost, on rehab effectiveness, and we want to move as those results come in. Really expected that this process is going to ultimately meet our objectives and bring in considerable cost savings over what would have been achievable with traditional planning approaches. Thank you all today, and please share your questions.
All right, thank you.
All right. Well, thank you all for attending this presentation. I'm Daniel White with Jefferson County again. So we do have one question that's come in. What was your experience with the optimization process as a utility, and what did you get out of it versus traditional planning? So when we think about that, really there was two things that really stood out for me versus the earlier process coming out of model development, what we call remedial measure planning, looking at those improvement projects, really being focused on what is the effort to be able to eliminate the SSO, right? And that was really the focus in that initial phase. And then going through the optimization, we can step back a little bit and say, all right, let's take into account this asset and its life, and being able to think about asset renewal. Ideally, we would have a curve that showed the useful life of the asset, right? And we would take action then and renew it, immediately before failure at the most effective point, the most cost-effective point. That's not always achievable, right? But we know there is benefit to doing CIP renewal. And if we do it a little bit early, right, that's not lost, right, in the equation with optimization. We can take that benefit into account and use that in our total planning. Is there any stormwater entering the SSO system? So Jefferson County operates a separate sewer system that acts very much like a combined system during rain events. So, part of this, when we say comprehensive rehab, we are going through and doing a lot of television inspections, smoke testing at times, of a very robust flow monitoring network. And, if you saw those early slides where we talk about, 80, 90% I&I removal, a lot of that is through lining over abandoned services and doing a lot of upfront engineering work and investigation work to say, don't open that service just because there's a dimple, which might have been the standard procedure back in 1998, 2004. You put the burden on the contractor to go open the services versus us now, going in and closing those and trying to remove the stormwater connections or I&I connections. So another question, how were the I&I reduction levels chosen? So David and I can kind of both answer this, but it's really a proportional response to how bad that area is. So when we look at RTK values, if they're extremely high, over 30%, and even higher than that sometimes for Jefferson County, we are not playing in the 5 to 10 range as some systems might. We believe there's a greater opportunity, and that's built off our past experience going through into pilot projects and areas to see what is actually achievable. So David, you may want to just add to that.
Yeah, that's right. So I know you guys had a very significant I&I program already in place. And so we saw some parts of town had very high levels of I&I reduction that were achieved. So we were able to include those higher levels in the optimization itself. Now, the optimization was able to choose the level of I&I reduction out front in 10% increments. So if a catchment was selected at 50% I&I reduction, for example, the optimization had a choice to go 0, 10, 20, 30, 40, or 50, depending on what was the most cost-effective balance between the I&I reduction and the improvements that it was offsetting, where that was conveyance or storage, as an example.
So David, another question has come in. How long did this project take to complete? And so for the purpose of this answer, let's really just talk about the optimization portion, of the work.
Right. So the hydraulic model had already existed, and it was calibrated by Hazen. And so once that was done, then we started the actual planning process of developing the alternatives and building up the optimization. So we were able to run through the optimization and complete prioritization in about 3 to 4 months from when the time that we got the model in our hands to actually giving final deliverables back to Jefferson County and Hazen.
Right, and I guess that was for our first effort. We had isolated out the Valley Creek Basin, which is our largest sewer basin, and after going through that, then we came in and stitched together the whole all the various interconnections. Correct.
That's right. Yeah. So we did have an initial, what we call just a demonstration or pilot project on an individual basin for the county. But then we did come and bring in the entire system. And so when I talk about the 3 to 4 months, that was for the second effort with the whole system. The initial effort with the demo took probably about 2 to 3 months on its own as we worked through the beginnings of that project.
And it was very much a collaborative effort between the county, Hazen, WCS on the cost models, the asset life, assumptions, and all those things. So.
Yeah, that's right. We could not have completed this project without direct engagement from all the stakeholders involved. We did not just take the model, disappear for 3 months and come back with results. This was a very collaborative project. We were meeting weekly, having several major workshops with the client and Hazen. I don't see any more questions coming through just yet, but I know time is approaching the end here. I do want to say that this was an extremely successful project. We did have a lot of great outcomes from not only the optimization, being able to select a
a viable strategy for the county. But the prioritization really helped to drive that home and show which projects were really provide the most value to the county.
Right. Yeah. The whole phased approach of being able to come in and really get those big volume reductions early with, because we're talking big dollar, I shouldn't say minimal investment, but a small percentage,
right.
of the investment.
Yeah. It's too often you guys get these large CIPs and no idea. Okay, well, what do we need to do first? And it can be very overwhelming.
Right. And because so much of the solution does involve that comprehensive rehab approach, those can be delivered a lot of times much faster because we're not dealing with right-of-way acquisition or things like that can really delay a traditional capacity improvement type, sewer enlargement, sewer replacement job. I don't think we have any more questions.
I don't see anything else that's come in.
Yeah, appreciate everyone's interest. Thank y'all.
Yeah. Thanks to WEF for holding this online event for everyone. Thanks to Hazen for being a great partner, and thanks to Jefferson County for also being a great partner in this project. It was very successful, and we're looking forward to seeing it implemented.